Hi everyone, welcome back to my channel. So in this video, we are going to look about recursive functions in Java. So basically how we declare a function, we just give static, return type of the function is going to be void and just say, I'm going to say greeting. Just say hello world. Basically this is how we define a function in Java, right? So what we do, how we call a function, we just say greeting. Just run it. Okay. Hello world is being printed over here. What if I say that I need to print this function, say I need to say 5 times hello world without using loops. What will you do? Okay, let's just copy this statement and just do. Now if I run it, we'll be getting 5 hello worlds. What if I say that you should not modify this body of the function? That is, you should be having only one statement over here, but you should print 5 times. Okay, now I could call the function 5 different times. Just now if I run it, hello world is printed 5 times. But what if I say that you need to call the function only once, and in that function you should be having only one print statement so that you could print 5 different hello worlds. Okay, you might be thinking, okay, how can we use that? Right, just having, let me change it to greeting 1. Since we cannot have more than one line in a function and we need to call only one function, we could declare several functions. Let me copy this and just paste 5. I'm just going to rename every single thing because functions cannot be of the same name. Okay, there is one function extra. Okay, now I have called this. But what I need to do, first understand the control of the Java execution programs. Controls will be starting only from this main function. It will enter, it will see what is the line inside the main function. It just says calling, it says calling the greeting 1 function. When this line is executed, it just right away passes to here. Now it just prints hello world. I don't want, after this hello world, this ending braces are seen, it just goes here and the main function is finished. When the main function is finished, nothing is going to get executed. So I don't want to end over there. I need to execute another function. So I'm going to call greeting2 over here. Now just is greeting2, come over here and print hello world. Now I could call greeting3 over here. Now after this I'm going to call greeting4. Now in this greeting4 I'm going to call greeting5. Now after all this, okay, let's run this first. Oh, okay, now let's run it. 5 different hello worlds are here. How it's happening? We are calling greeting 1 inside the main function. Now the control flows over greeting 1. Inside this greeting 1, we are calling another function greeting 2. Now after this, it will come over here. Now greeting 2 body will be executed. Now greeting 3 is called. It go print this line. Greeting 4 is called. Go to this function, print this, and greeting 5 is called. Go here, print this. After this, when this ending braces are seen, you just go to there. Now this function is ended. So now only the greeting4 function will be exited, because till then the greeting4 is also inside this stack memory. After this, now we go over here, greeting3 will be executed. Now greeting3, now greeting, it goes to greeting2. Greeting2 will be finished. Okay, what will happen? Go to greeting2. Now after this, it will be going over here. Now this one will be finished. Right now only greeting1 will be removed from the stack. That is, its execution is over. Now after this gets completed, now only the main will be main work is done. So actually in the stack memory, understand one thing. Main is the first thing to go inside the stack memory. So it would be the last thing that is going to get out of the stack. So the thing that goes first inside the stack is the last to come out of it. So main will be the last one to come. Greeting 1 will be the second last, then greeting 2, then greeting 3, greeting 4. Greeting 5 is going to be the first thing that's going to get out of the stack. Okay, but can you see something common over here? All these functions are having literally one line. That's also the same line. So why I need to call several times? Why I need to call this several function, these functions several times? That's where we use recursive functions. Let me remove all this. What if I say just print numbers from 1 to 5? We'll be just using what looping statements, something like that. But now we are going to use recursive functions. So I'm just going to print it. So it's be void. So I'll just say print. Let it be print function. Print function, I'm going to take a number. What I need to do, I need to print that number. Okay. Let's take my number print function 5. If I give 5 means what should be my output? 5, 4, 3, 2, 1. After 1 it should be exited. But what will happen now if I run it? You could just see only 5 will be printed once. I need to print it several times. I don't want to use several function calls and several functions because it will be called one after another. I don't want to do that because I know that my body of the function is going to be the same. So I'm just going to call the same function itself, print function. Now I know that 5 is already printed. I don't want 5 to be printed again. So what I need to do? N minus 1. You could think this as the increment statement in the looping statements. In the looping, there will be something called incrementation. We will be incrementing or decrementing that. Now we are decrementing. So you need to be very clear in the function call what arguments you are passing, whether you're going to increment or decrement. Now if I run, it will be an error. That is infinite iteration will be happening. See? What is that? Exception. Stack overflow error is happening. Why? Just think about it. For this, let me use loop over there. For int I is equal to 0, I less than I greater than. Okay, what I need to do? I don't say anything. I greater than minus 1, I plus plus. Now if I try printing it, what will happen? I is starting from 0 and it's just going to get incremented. So 0, 1, 2, 3, that's how it's going to be incremented. I greater than minus 1, it's always going to be true that 0 itself is greater than minus 1 and every time I'm just going to just do incrementation, then how my I value just go be less than minus 1. So this is what we will say that infinite times loop is running. There is no stopping case. It will be running. Okay, go call again. It will be going and calling 5, 4, 3, 2, 1, 0, 1, and minus 1, minus 2. It will be running like that. So I need to have a base case over there. Base case is the one that's going to restrict it. Okay, this is the endpoint. Just stop it. I'm just saying when I need to stop. If n is equal to 1, that's going to be my last statement. What I need to do, I just need to print that 1 and just stop all my execution. So we are using return statement over here. Let's run it this time. 5, 4, 3, 2, 1. To make it much more clearer, I just remove this line because I don't want it. From 1 also it's going to get printed. When will it stop printing? When it is 0, right? So now if I give this, it works. It makes much more sense because when the value reaches 0, you need to stop it. So this is what we call base condition. Base condition is must in every recursive functions. Okay, without a base condition, our function start behaving as an infinite loop. It just runs without any end. So that's why we call it as infinite loop. So here it will happen, stack overflow error will occur. It will be an infinite iteration. Okay. Okay, this is very much clear, right? What if I say I need to say hello world for the 5 times? That's our first example, right? Where is it? Let's take static void greeting. I need to print hello world 5 times in recursive manner. How can I do? I'm just going to call this greeting. Now I'm going to take a parameter in n. N is going to specify the number of times I need to print this. So let's say 5. 5 times I need to print it. How will you do that? Just think how you solve a looping statement. If n equal to what should be the case? If n is equal to 0, that's the endpoint. I just say return. Now what I need to call once it's printed, I just need to call the greeting n minus 1. Now let me try running it 5 times. If I change it to 10, hello world is printed 10 times. This is how we use recursive functions. Okay, the most common example that people always do with recursion is factorial. So you try doing factorial. Just be clear with one thing. If you have any doubts, you could ask in the comment section. We'll be solving it in the next video. Just what we say factorial, say 5 factorial. 5 factorial means actually what it is. We need to say 5 times, 4 times, 3 times, 2 times, 1. So what should be my base case? When my number is equal to 1, just return that. Okay, I could even write for that, because it will be much more clear when you work with the different types of recursive functions. So I need to say static it. I'm going to return my value to the main function. I'm just going to print in the main only. So I'm just returning integer value. Factorial. I'm going to take a argument n. I need to find the factorial for this n. Actually in mathematics we have a formula, right? 5 factorial is equal to actually what? We can write as 5 times 4 factorial. This is what we have seen in factorials, right? So I'm going to create a variable int x is equal to n times what we need to do 4 factorial. What is factorial? Just call this n minus 1. It's much more clear, right? 5 factorial is equal to 5 times 4 factorial. So 5 times 4 factorial. Now what I need to do, I just need to return my factorial answer to the main function. But where is the main case? Base case. If my number is equal to 1, what I need to do? I just say return 1. Okay. Let's try printing factorial of 5. 120 is over here. Factorial of 4. 24. 4 3s are 12. 12 2s are 24. 24 times 1, 24. So you might be asking, okay, everything is clear. Why do I need to return 1 over here? That's the condition. Okay, let's trace it manually. Let's put a debug pointer over here. Debug it. What's going to actually happen? 4 is coming in. Is 4 equal to 1? No, it's false. Now what will happen? 4 times 3 factorial will be there. Now factorial is 3. Is 3 equal to 1? No. Now it will happen. What will happen? Now it is a new variable x. It is a new variable x. So 3 times what is the factorial of 2? Is 2 equal to 1? No. What will happen? 2 times factorial of 1. Now 1 equal to 1? Yeah. Now it's returning 1. What will happen? It will come to the second case. That is when the value of factorial 2, that will be over here. What is that? 2 times factorial of 1. What is factorial of 1? I have written 1. So 2 into 1 would be over there. So 2 into 1, 2 will be stored over here. It's just returning x. Where it is returning? It is returning to the previous function call of n is equal to 3. Now n will be 3. N times factorial of 2 is here. Factorial of 2, I have written the value as 2. Now it's 6 over there. Just returned it. Now it's going to the first condition that we called 4. 4 times 3 factorial. That is 4 times 6. Now 24 would be here. 24 would be returned to the main function. That's how we are doing. Now just showing a error mark over here. Why? Every time we don't need to create this variable x. Let me just copy this and paste it over here. Now also it works because you don't want to create a create a variable that's going to create every single time. You know that it is a thing that's going to happen. Just give it in the return statement itself. So this is how we do a factorial. We calculate factorials in programming. Okay, let's try printing one last example of Fibonacci sequence. Okay, let you try Fibonacci sequence. If you have any doubts, do share in the comment section. We'll be solving it in the next videos. So hope it is clear. Thank you for watching.